This week we're going to look at subnetting, because that's in the chapter y'all should be in. Because y'all are in 8, is that right? Okay. Hopefully April, I'll be here all month. So today let's look at number systems, and we'll get to the subnetting if we can, or for sure we'll go through the subnetting on Thursday, because you got to know number systems to be able to do the subnetting in IP version 4. IP version 6, you just want to use that fourth octet. Test out's confusing me for a second there. And that you'll just assign a number in there, and that'll be your subnets. And you don't have to worry about borrowing or anything else. You've got an entire octet reserved for subnetting in there. Okay? So IP version 6 is a whole lot easier for subnetting than IP version 4. IP version 4, it gets confusing. Before we get on into that stuff, I was mentioned to you they do have the health fair downstairs today in the conference room area. So if you want to drop through there after class and pick up anything, if you didn't go through it coming up. So they've got some different things in there. It's not just, they've said a health fair, but it's more than health fair, because they've got information on several colleges to transfer to, etc. And there are several other things, and they were still setting up when I walked through it a little while ago. And there's a couple other organizations got some stuff in there. So I did walk through it a few minutes ago. I think that's it. So, with subnetting, the object of it is to be able, that you've been given a network, and to break that network into smaller networks, and that you want to be able to split it apart into smaller ones. That you were given some network address, and then you decided that within your organization you want smaller networks making up your big network, which obviously increases controls for you on it, and that makes manageability better, and also limits some of your other things occurring out there, keeps your traffic down, etc., and just on the area it belongs on. So with IP version 4, if you're setting it up from scratch, and you're normally going to be using NAT anyway with IP version 4, that my suggestion to you would normally be, as far as an easier approach on it, is don't go take a Class C address to assign yourself, even though you're sitting there and saying we got less than 254 machines on our network. Don't use a Class C address, use a Class B or Class A, of using either the Class A 10 address or the Class B 172.16 through 172.31. By using a 10, all you've got is that first octet reserved out there. You've got the other 3 octets to play with. . If we use a Class C one, you're picking a number just for your network of 168 point something. I'm going to put an X there, points, and then your host numbers for the last octet. Okay? Do I follow on that? You can use this one, and with what we're going to look at the next 2 days, you'll see how you split it up, and that you can split this into multiple networks in there. With the 10, you can split it up based on your octets and not have to worry about all the math stuff we're going to have to look at in terms of borrowing from that last bit, the last byte to get your subnets. You can designate this octet, for instance, for your subnet numbers, and assign, if you had how many ever subnets you wanted, assign them a number here, and then use these last two for host, or you could actually use these two positions for subnets and the host within the subnet, depending on how many hosts you're needing on your subnet. But if you're having 254 or less hosts on your subnet, you could use both of these for your subnets. Or you could use this one that you've given yourself 65,000 or something like that host per subnet. So I follow on that, and that you can assign a real easy method of just keeping track of it right there with no arithmetic involved. That's subnet number 1, the 1 there, 2, 3, 4, 5, 6, and so on through. Okay? Up to 255 of them. And then just assign your host numbers per subnet here. Makes it a whole lot easier. Now, prior to doing that, when you were assigned a specific public address network that they gave you, and still out there some because of how addressing has been set up by organizations, because they didn't do what I just told you right here, you've got to sit there and go in with the naming convention they already got, whatever the number was they had, and we're going to be using this as our number up there on it, but usually you'd be using a public number, okay? But we're going to just use a private number for our demos on all the stuff. And that way we're not using a real number, right? But in that case, if we had this network, let's just assign that as a, go ahead and give it a number. I'm going to call it 3. Just picking a number out of the sky. Okay. We had a network that had 254 hosts on it. But now, one of you has come in and said, wait a minute, the way our network is now, we could manage it a whole lot better if we split it into subnets. You can do that using that address still right there. You're going to have to renumber all your individual machines out there. But you can borrow from this host portion here, that you can borrow some bits of the host portion and use them into the network portion. And so then you're going to use a couple of bits on the left side. Could be 1 or more bits. Normally it's going to be 2 or more bits, because 1 bit really doesn't do you a whole lot of good. But you could do 1 bit if you just want to split it into 2 subnets. Okay? You could borrow 1 bit and split it into 2 subnets. And then the remaining bits will still be host numbers within those subnets. Now, you're going to lose host addresses. So you won't be able to have 254 hosts on your network anymore, because you used numbers for network numbers, and you lose a few other numbers in the process. Does everybody follow what's involved here with subnetting? Of what we're trying to do and what's going to be involved. So we're going to be borrowing off these 8 bits. And instead of this being the spot where the network address ends, it's going to be somewhere over in here, depending on how many we borrow. Let's say we borrow 2, that's going to be our spot. It's going to change subnet mask also. So no longer will it be 255, 255, 255.0. It's going to be 255, 255, 255 dot. And then we've got 2 positions here, in this case, reserved. So in that case, it would be 192. Okay? So that we know which bits belong to the network, which bits belong to the host. So everybody got a general little idea there of what we're going to try to do. Now, to do that, it's going to require a good bit of math to do it. first part is, if you noticed, I threw it in binary there. So you're going to have to understand binary. Okay? It's not going to be dealing with hex, so we really don't have to deal with hex here, although I've already shown you hex. Okay? But let's look again at the binary and how binary works. Because the binary is going to be critical to it, to figuring out those addresses. You've got to break it down into the binary, see where it splits on, and then do your calculations to get the host address versus the subnet portion of the address out of it. So if we go back to binary, in binary, how many single digit numbers did we say there are? Two. What were they? Zero and one. And decimal, how many single digit numbers have you got? Come on, y'all. Y'all use it every day. How many single digit numbers you got? 0 through 9, which is 10 of them, right? Oh, you got 0 all the way down through 9. And that gives you the decimal. Hexadecimal, remember, it went on for 16 of them, and what did we use after we got through 9? A through F. Okay? So letters became numbers. So in this class, I have taught you that letters are not always letters, contrary to what you've always been taught up till now. And I've told you on doing, when you're setting up your interfaces on your routers and switches, to use a double negative. So I'm messing up everything you've been taught along the way. Remember, you got to do the no shut to start. Of course, that's sort of like in Windows to shut down. You got to go to start to shut it down. Neither one of them seems to understand plain English. So, zeros and ones and 9. Once we get to the biggest single digit number, we're going to put a 1 in the next column and put a 0 in that first column. So that here, 10 was our next number, right? Here, 10 is our next number also. Okay, so everybody follow on that? Now, let's look at column values. And these are important to you. In decimal, what are our column values? Think back first, second, third grade. What is the different columns values? What comes first? I couldn't catch what you said. 10? Yeah. It's not the first one. What comes first? Ones. You got the ones, you got the tens, and you got what? The hundreds and the thousands, right? Everybody remember that? Like I said, think back first, second, third grade, somewhere back in there. That there is 10 raised to the power of 0. Any number raised to the power of 0 is always 1. Okay? That is 10 raised to the power of 1. Any number raised to the power of 1 is always itself. Okay? That is 10 squared. That one you probably know. Because as far as raising the powers, squaring is usually the thing that most people remember. Because that's 10 times 10 gives us the 100, right? That's 10 cubed. Okay? And they just keep on going like that. That's where we're getting on the decimal. It's what you already know. But that's why I'm showing it to you, is You may not have realized this part, that that's where those column values come from, okay? That's why it is ones, tens, hundreds, thousands. If we look at binary, that's an R, believe it or not, and a Y. It's going to work similar to this, except this was base 10, this is base 2. So this first column is going to be 2 to the power of 0, 2 to the 1, 2 squared, 2 cubed, and so on. Everybody follow on that? So we're following the same way as this one. Okay? 2 to the power of 0 is what? 1. As if you were paying attention up there, you knew that answer. 2 to the power of 1 is what? 2. 2 squared is what? 4. 2 cubed. 8. So they're just doubling, okay? If we went back to our hex, it was 16 to the 0, 16 to the 1, 16 squared, and 16 cubed. And don't ask me bigger than that, okay? 16 to the 0, all of you can give me that one. 16 to the 0 is what? 1. 16 to the 1 is what? 16. I'm going to write it sort of sideways because we're talking about just one column here, okay? 16 squared is what? 256. And 16 cubed is what? 4,096. Is that correct? 16 to the 4th is something like 62,252. Give or take a few. And then it just gets huger and huger, okay? That's the columns, okay? Now, if we want to convert a number from one system to the other, we're going to need to know those column values. So that if we want to take the number 18 from base 10 and convert it to binary, okay? And in binary, the only thing normally all you're going to need to worry about when working on the computer is going through 2 to the 7th, okay? Which actually is 128. But pretty much, you just have to worry about the first 4 positions on the different ones. And actually in hex, usually you don't have to worry about beyond the first 2 positions. So if we're going to take 18 from base 10 and we want to put it in base 2, then we're going to put, if it's a different number system, we're going to use a subscript on it and tell it which number system it is. If it doesn't have a subscript on it, we're going to assume it's a decimal number. But remember, now we're working with several number systems on doing number systems, so we probably want to label them, because that there is a legal number in all 3 number systems we're talking about. Totally different values depending on which number system we're talking about, but it's a legal number in binary, decimal, and hex. Okay? So we got to know which number system are we talking about. Now, if it's a binary number, we know it's only got 1s and 0s, but a decimal number could contain only 1s and 0s also. Does everybody follow on that? So 18 in decimal, what does it convert to in binary? Okay. If we will number our columns until we get to a number bigger than 18. So 1, 2, 4, 8, 16, and then 32 is the next one. Okay? We're not going to use the 32's column, but best bet's go on to the next bigger one. You could have stopped on 16 because you knew the next one was bigger, but I always go one bigger. 16 will go into 18 how many times? Once. So we'll put a 1 in the 16's column, subtract 16 from here, and we've got 2 left. Will 8 go into 2? No, so we'll put a 0 there. Will 4 go into 2? Nope. We'll put a 0 in the 4's. Will 2 go into 2? One time, right? So we'll put a 1. Subtract 2 off. We've got 0, and it's not time to quit yet. Will 1 go into 0? No, so we'll put a 0 there. Because if we don't fill out the remaining spaces, we got the wrong answer. So 18 in decimal is equivalent to 10010 in binary. Does everybody follow that? That's the equivalent number on it. You'll a lot of times see them use equal signs right there, but it's really not an equal sign belongs there because we're talking about two of the same value, and so we're really equivalent, not equal in a technicality there. So I'm going to use the equivalent sign, but if you look in the book or you look in other places, you're going to quite often find an equal sign there. So just be aware that basically the equal or the equivalent symbol is going to be about the same for you there. And that, depending on where you're looking at, depends on what you see. All right, questions on how I did that one there? Y'all see that? Okay. Let's go backwards. If we want to go from binary to decimal. Okay. So I'm just going to create a imaginary binary number. This is binary, and I want to convert it to decimal. That's what's stored in the computer. We want to know what is it a number that we're used to dealing with. 101101, and binary is not something you normally work with. Now you can sit there and use your little calculator in Windows and it will tell you what the equivalent number is. But y'all need to know how to do it, because to do that subnetting where I was just talking about borrowing bits, you got to know what you're doing. So in this case, we'll number off on the binary number the same column numbers like we did a moment ago. The 1s, the 2s, the 4s, the 8s, 16, the 32s. Every column that has a 1 in it, we're going to add up the column value. Does everybody follow that? If there's a 1 in the column, we're going to add its column value together. If there's a 0 there, we're not going to do anything with it. So we got a 1 in the 32s, got a 1 in the 8, a 1 in the 4, and a 1 in the 1s. Add them together and we get 45. So our equivalent is 45 and base 10. Okay? So if you want to make somebody seem real old, convert their age from decimal to binary. Because if they were 45 years old, you can tell them they're actually 101,101. Okay? So they've outlived Methuselah. But that's to convert from binary to decimal. Questions on that? Let's go ahead and look at hex also here. So, they got 185 in decimal. Now let's convert it to hexadecimal. We're going to again look at columns like we said in binary, but we're going to run out of columns real quick of how far we got to go. We're going to have the 1s, the 16s, and the 256s. So the 16s columns, first one we're going to deal with here. In binary, it can only occur one time in there, so we just had to worry about that 1. If you get anything other than a 1 and a 0 in binary, you made a mistake. And here, we know 16s will go into here. The question is, how many times will 16 go into 186? Okay? So you're going to divide that out and see what you get. You should get 11, I believe. Okay? But we can't put 11 here because 11 won't work as a single digit number. It won't fit in one space. Okay? Sort of like out in the parking lot, there's one space for each car. It doesn't work real well if John and I both try to put our cars in the same parking space. Okay? Probably can do it, but our cars aren't going to look real good when we get through with it. So let's not try it, John, okay? I don't know if you pried your car or not, but I'd like to keep my car around a while longer. So, 16 into there, we said it's 11. And if we come back over here and look at hex, so we had 0 through 9, and then we had A through F. A was 10, and so on down to 15 is equivalent to F. Y'all follow on that? B is 11, C is 12, D is 13, E is 14, and F is 15. So we got 11. 11 is going to be the letter B. So we'll put that as our number here in the 16s. Well, that was 176, so we subtract that from here, and we got 9 left. 9 will work as a single digit number, so we will put it here. Everybody follow on that? So B9 is equivalent to 185 in decimal. Okay? It's the same value. Now, if we had have converted the 185 in base 10 to binary, what would we have gotten? We would have had the 1s, the 2s, the 4s, the 8s, 16s, the 32s, 64s, and the 128s, and 256 was next. Well, 128 is actually 8 positions here. Why would 8 positions be important to us on the computer in binary? It's 1 byte. Okay? Think back to our addressing in IP version 4. Each of the octets represents 1 byte. So each of those numbers can only be 1 byte of information. So we're only going to be dealing with that, dealing with addresses normally. You have 1 byte on it. Everybody follow on that? So you normally don't have to go any further than here anyway. Now, what's the biggest number that we can put, decimal number that we can represent in 8 positions in binary? That would be 1s in all 8 positions. Okay? which would be the 128, 64, 32, 16, 8, 4, 2, and 1. Okay? And that last position, if there's a 1 in that last position, you're going to get an odd number when you convert it back to decimal. If there's a 0 there, you're going to get an even number, just for your information. So that is going to be 128 and 64 is 192, 224, 240, 248, 252, 254, 255. So that's the largest number, and if you think back, that's what I told you before when we were talking about the addresses the other day, of just the introduction to them. 255 was the largest number I told you could be there. Well, that holds. So in this case, 185 is going to put a 1 in the 128s. So I'll subtract off 128, which leaves 57. 64 won't go into 57. 32 will go once. Subtract that. 25. 16 will go once. Subtract that. I've got 9. 8 will go once. Got 1 left, so nothing in the 4s, nothing in the 2s, and a 1 in the 1s. This is what's actually stored in the computer. This is the number you deal with. If we go and dump out what's in the computer, it's a ton of these. And you want it to find something in there, a specific one, and you used to have to do this more often, you don't have to do it very much anymore, that you would actually dump out the memory of the machine. And you could dump it out in binary. And you actually do have it come out sometimes still on some error codes, etc. for you. If you got it all in binary there, you could end up with a page of 1s and 0s. And then going through and trying to find the specific one you're looking for to see what was actually stored there. What's going to happen to you when you start looking at all those 1s and 0s? It's sort of like those little things that are being passed around on Facebook some, of where you're supposed to look there and find where the different looking character that's almost the same, see if you can find it in there. Okay? You all know what I'm talking about, right? Where they give you a, looks like field, if I can't remember the characters they use on it, and it's got some other character that's almost the same scattered in there, or just one of them, and it says, can you find it? But there's one of them is wrong. You can imagine doing that with this. Okay? Putting it instead in hex gives us the exact same detail information, because that B tells us what's in the first half, and the 9 tells us what's in the second half. We get a fourth of the numbers printed on the page, and they're not all the same 2 numbers. We're getting 16 different characters printed for us. Makes it a whole lot easier for you to find it. Okay? And to go look, and you're seeing it to the detail, just like looking in binary. You can just convert the one character you're looking for to binary and see all the individual positions. Does everybody follow on that? So the machine is going to work in this. We're going to work in this. This is just an easier way to see what the machine has actually got out there. Y'all follow? Now, the machine is also going to automatically just convert from here to here and vice versa going back out. But all of its internal workings is in here. Okay? Does everybody follow on that? So that if we convert this, if we go to convert then from hex to binary, we're going to convert it 1 hex character at a time to 4 binary numbers. Which means hex to binary is a whole lot easier there. Likewise, if you're going to convert binary to hex, you're just going to split the number into groups of 4 and convert each group of 4 back to hex. and that you're going to look at these instead of being all the way up to here like we're doing to decimal. All you got to worry about is up to 1248 and then 1248 again. And so we're staying with small things, and that just gives us those individual numbers. Does everybody follow on that? So if we were to convert that B9 to binary, the B would convert, so we know we got 4 positions for it, and the 9 will convert. Hopefully I drew those right. So there's the 1248, 1248. Now actually it's using the bigger and bigger numbers, okay? But for our conversion purposes, because it works out 1 column in hex, converts to 4 columns in binary straight, we can just deal with just 4, treating it like it's 4-digit numbers, okay? So the 9 would convert to this last 4 positions. 8 will go into 9 one time. Let's subtract that off, that leaves 1. 1 won't go into 4, won't go into 1, and 2 won't go into 1. 1 will. B is what number? In decimal. 11. 8 will go into 11 one time, right? Subtract the 8, we leave 3. 4 won't go into 3. 2 will go into 3. Subtract the 2 from 3, leaves 1. And we put a 1 in the ones. Does everybody follow on that? Not as complicated in some ways, because you're breaking it down into just having to work with it. And basically, think of it, you're working with a half byte at a time, or a nibble. So if y'all had have just asked me what a half byte was, I would have never been able to remember it was a nibble. For some reason I remembered on that right then. Questions on those? How that all works around there. So from like I say, basically don't worry about the hex for our purposes in here, but we're going ahead and just throw it to you there. We're worried about from decimal to binary and binary to decimal. We're only worried about up to 8 positions. Okay? Everybody follow on that? Because basically, you're just working with a byte at a time or 1 octet. And so you're going to be looking at that. Because what we're going to in turn do is that we're going to say, for instance, we want to borrow those 2 positions. And we know that this is then the network address, and this is our host portion, as opposed before the whole thing was the host portion. And so we have to look at the whole thing on. All right, questions on how we're converting the numbers? So everybody got it on converting from one number to the other number system? What the single digit numbers are in each number system. And remember, when you get the largest single digit number in a number system, the next one is 10, okay? Because you're just carrying over to the next column. All of what I just taught you here will work with whatever number system you want to work with. Okay? So Mark, for some reason, decides he wants to work in base 33. He can actually do it from what I just taught him up here on this board. Or if you want to be an ancient Babylonian and work in base 60, you can do it from what I just showed you. Okay, because it works the same. The only thing we don't know is base 33 is no problem. We've still got enough letters to do that. Base 60, if we're trying to work with that today, I'm not exactly sure what all your single digit characters are, because we've run out of letters and numbers But actually, I think we go to Greek letters, but alpha, beta, and then I don't know what comes as the next Greek symbol, okay? So that doesn't get us very far, okay, on it. So, and actually what the Babylonians used, they had some symbol for each one of those. So they had 60 different symbols for their single digit numbers, but they weren't using Arabian numbers, okay? Where the world today is pretty much all on Arabic numbers. Everybody follow on that? Although you could have a number different, but really if you go language to language, everybody pretty much in the world works that approach. It's peculiar in some countries too that there can be a completely different language and yet they'll use English characters for some stuff. When I was in China, it was amazing to me that I could read all license plate numbers. Couldn't tell you what state or that information was on the license plate because that was in Chinese. But the actual tag number was regular Arabic numbers and English letters. And I questioned them on it and they said English letters were distinctive and clear to everybody, and even the visitors to the country everybody could read English letters. For Chinese characters, trying to read them at faster speeds, etc., was a whole lot harder. So they went with English letters in China. Peculiar. I'll see what happens when I go to France this summer and see what they've got on their license plates. But I know they'll have regular letters, okay, because French is using the same letters. So, all right. Does everybody follow how the number systems, what the three number systems are, how to convert between them? So I'll go through some more for you. There are handouts in Chapter 8 in Blackboard that there's a 32-page handout there that you can go through that has lots of problems for you to convert from number system to number system. It also has subnetting stuff that we'll do Thursday. So that stuff you can't do yet, but if you want some problems to do, the answer manual is out there also. So if you want to just convert some and see if you got them right or not, you can do that and you can look at the answers. And the answer key, as far as I know, is correct. A number of years ago, I started using the thing because Cisco actually gave it to me, but they didn't give me the answer key. And then I had a student do the answer key, and she made a few mistakes on it. And so that's been fixed over time, and nobody said anything about any answers being wrong for a number of years now. So I'm pretty confident that all of the answers are correct. There is my handout out there also about binary to decimal. Okay. And that's I think that's a 3-chapter handout now, if I remember right. It used to only be a chapter, but I think it's 3 chapters now. The PDF is sitting out there for you. It is actually a book out there that I've got published out at Barnes & Noble Nook, the electronic, the ebook on it, that you can go out to Barnes & Noble and pay 99 cents and buy it if you want, or you can get it for free through the notes in Blackboard, or you can actually go to my website, look in my articles page, and you can get it for free there too. I still managed to sell a few copies at the Nook, even though it's sitting out there free on the internet on my website. I redid it a couple of years ago into 3 chapters, I'm pretty sure it is now. I think it's 3 chapters. It's a little bit bigger, that I did a little bit more with it. The other part I need to still do with it is and that I've wanted to do since I first wrote that a number of years ago and not had a chance to do the other part I want to do, because I went through the hexadecimal part into it also. And actually I need to do that now for my class, for the CIST 1001 class, because they're actually supposed to learn about hexadecimal numbers and binary numbers. And so I'm going to give them that handout, and because the book really doesn't cover it, that they're taking. And then hopefully I can sort of sit there and real quick write up stuff on hex. Because I should be able to just take what I've got written on binary and go through and edit it into hex and decimal and work fine. And not have to write all from scratch. And that was something I was hoping to do last week, several weeks ago, but then March got messed up. Any questions on that? It seemed like everything hit in March. And I was trying to do my travel this morning in March, and I was approved back at the 1st of March to go to North Carolina. They don't even have that sitting out there anymore on me, and I was turning in my travel stuff for it. And then actually I didn't get approval to go to Atlanta there the 23rd, 24th, and 25th for Skills USA, because I got told I was supposed to go. And so hopefully that goes through smoothly, that I had turned that in without having anything out there showing an approved trip. Does everybody follow how the number systems work? Sometimes the number systems gets confusing to students. It's new and different for most of you. Because most of you, all you have done is fooled with decimal. But that's where I wanted you to see, like I had down here, where I showed you how the column numbers were come up with. They all work similar. It's not something different. A lot of things that go to show you on how to work with binary or whatever, they just tell you about it's the 1s, 2, 4, 8, 16s, but don't show you where those numbers came from. And that I want you to see it's working the same way you worked in decimal that you already know. Now, why are you using decimal? Why do we use decimal as our number system? How many fingers you got? 10. Okay. Why does the machine work in binary? Why don't we have the machine work in decimal? So after all, humans invented the computer. Why not make it work just like we do?
Can't have it count to 10.
You can have it count to 10, but how is it working? It's an electrical device, right? So what is everything basically out there in it in a state of? Whether we're looking at where it's stored out on a disk, or if it's sitting in memory, or whatever. What's the situation most of us all looked at as being there? What's the easiest thing about electricity to determine? It's on or it's off. Okay? If we're looking at it stored magnetically, either there's a magnetic bit there or there's not a bit there. Okay? If we're looking at the CD, either it's burned a hole in the CD, not burned it all the way through, but just burns it in the surface, or there's nothing burned right there. If we went to decimal, we'd have to try to figure out how big of a hole did it burn, or how much is the power turned on. Because it's a whole lot easier for y'all to tell me the lights are either on or they're off, right? If you got a dimmer switch on one of your lights at home, can everybody agree on the position it's at the point where everybody says this is the right position for it now? And then you decide later you want it set back to that position? Is there an easy way to do that? That the lights were 45% on. Savannah trying to turn that knob and get it to 45% gets tricky, right? Because she goes, I got it at 45%. I walk in and look at it and go, no, those are brighter than 45%. We got to change it down some. And we can't decide on what 45% is. But electrically, it's easy enough to either say it's on or it's off. So binary works great for that. And then hex, like I said, is purely as a way to show what's in binary in a shorter, easier format to read. Okay? It's really not storing it in hex out there. All hex is just a way to just dump it out where it's literally showing us what's literally there without showing it down to the little detail and drive us crazy looking at zeros and ones. Because literally, if I gave you all a whole sheet of paper filled with all zeros and ones, and I did have to look at those in college when I was taking programming, when we had core dumps sometimes, you will go crazy when they tell you that your error number is at the 100th, 0 or 1, the 100th position in there. Dump it out in hex instead, and we just got to split that by 8, and that we only have to look for the 12th position then for it. And then break that number apart, and we know exactly what the number was we were looking for. Whole lot little easier there, and not as likely to drive us literally crazy. Which shouldn't be the object of the computer. All right, questions on all of that? All right, Thursday. So I've given y'all, I think, a full amount of stuff right here. Thursday, we will actually submit it. Now, I will fill this board up a couple of times doing that, showing it to you, and how we break them apart. Okay? Any questions on that? Because I could go ahead and start on it, but I think I'm just going to confuse y'all trying to throw it all in one day at you. That I think it works better to split it in 2 days, so you got a day or so to digest what we went over today, because when you wake up tomorrow and figure out, wait a minute, I don't remember exactly what he said on that, get it back straight on it, and then us come in and start digging deeper on it. Because there's only so much our brains will handle at a time, or we then go to confusion and you don't learn anything. So, on that note, unless y'all got questions, I will let y'all go early. Any questions? And then we'll look at the subnetting itself Thursday. But this is the big piece of it. And if you've got this, the subnetting will fall in place. Although if you go and look at that stuff still right now, it may still look confusing. Okay? So my recommendation to you is do not take the test until after we have class Thursday. For most of you, I know that's no problem. But for a few of you that try to stay ahead, that's a recommendation to you. In this chapter, wait till we get through the lecture. Okay? Now, you've also got out there the video lecture that I did in 2004 or so, showing how to do it, where I recorded it on the camera for you and filled the board showing through it, where you can watch it. It's exactly the same way done now as it was done then. That you've got several different ones of those out there and stuff too, so you can go ahead and listen or watch or whatever. And if by chance any of you can't come to class Thursday, you can still actually see video on it, not just listen to it. Which on this one is a whole lot better video with it, because you really need to see what am I writing on the board while I'm doing it, not just hear me tell about it. Some of the other stuff, if we don't have video with it, it's no problem. My describing of it does a good enough job. But like I say, I do have video out there, which is actually sitting on YouTube, I believe. And actually, there is a large number of people have viewed those videos out there. Now I've got it split up, so if it's the hour-long lecture, it's split like into 6 parts. That's to keep it down in size, and also I think back then I had to break it down into 10-minute segments because YouTube wouldn't let me put out there bigger than a 10-minute segment, where YouTube will let me put out there a couple of hour video now, that they have kept increasing their limits on it and stuff, and keep raising me up to whatever the biggest thing is they'll let me put out there. So I'm putting them out there in 30, 45, 60-minute pieces out at YouTube now. Because as a matter of fact, y'all's audios are going out on YouTube as 60-minute or 70-minute video files, although it's really an audio file, because YouTube will not let us put an audio file on YouTube. And then y'all said there were different ones that said there was a problem with TeacherTube, and I figured out how to convert audio to video. Takes a while. If I can get my Premiere Elements to work, I've been told it will work a whole lot better for me than the program than Movie Maker from Microsoft's been doing, that it will do it better and faster. And I just discovered I still got Premiere Elements on my machine, but now it appears that's not going to work for me. I'll have to go buy another copy of it because mine is way too old and out of date, and that apparently doesn't work on Windows 10. But I'm trying to figure out a faster way for me to do it, because it's not exactly what I want to be doing every evening, sitting there converting several hours of files. Because like when I get home tonight, I'll have this hour of recording today to convert and upload. And with the Movie Maker, it takes about an hour for it to go through converting, it seems like. And then where I'm also doing a sermon for a preacher, putting out there for him too. So I'd like to find a faster way to do this stuff. Audio files I can work real well with because I'm using an old program that works perfectly well that actually went into Premiere, but so I'm going to play with that some more, because I did start playing last night trying to go back into Premiere again, and it locked up my machine each time I was trying to start it. And I actually left it after midnight as it was continuing to try to load and was getting about to the point where it would lock my machine, and just left it running to see if it ran long enough, if it all of a sudden cured itself and got to running on it, because I did see I need to get some updates, but you got to have the program running to do the updates. So maybe it's working when I get home tonight. All right, I will let y'all go, and I will see you on Thursday morning.